How's it going, everyone? Today we're going to be going over a practice question discussing paramagnetism and diamagnetism. So pause the video and try it on your own. All right, so this question is stating, MRI often uses intravenous contrast agents, so injecting into the vein, to enhance the visibility of blood vessels. To effectively create contrast, these agents must be paramagnetic. So I'll tell you, we don't actually need to know too much about the medical background here. We just need to know what the definition of something being paramagnetic is. So paramagnetic means that we're going to have at least one unpaired electron. Anything that would be diamagnetic, so diamagnetic, has no unpaired electrons in its orbitals. So every electron orbital is going to have those two electrons. So which of the following elements would be most suitable? Basically, if we want to reword this question, we're asking which of these following elements is paramagnetic. So you're going to get your periodic table of the elements. This is the AAMC version that I have here on test day. So let's go through each one. This is how I would do it. So magnesium, I know that's Mg here. I don't really want to write out the whole orbital like 1s2, 2s2, 2p6. I just know that these are the s orbitals, okay? So here's our s orbital. This is going to be 3s2, and we have one electron here in sodium and another in magnesium, so we know that last orbital is filled. So there are going to be no unpaired electrons, so magnesium is diamagnetic. Let's go to beryllium next. So beryllium, you might be thinking, ooh, I'm not sure where I can even find this on here. So you might have to scan a little bit. So you go first row, there it is. So Be, beryllium is what we're looking for here. So similar to magnesium, this is going to be our 2s2 orbital. We're going to have one electron in lithium, one electron in beryllium. So that orbital is filled. That's going to be diamagnetic. Let's take a look at neon. Okay, so neon we should know is one of our noble gases. So we have that 1s2 orbital filled up, 2s2. Now we're going to have to count electrons here. So in the p orbitals, we're going to have 1, 2, 3, 4, 5, 6. So there are 3 p orbitals in that 2p6. So we get 1, 2, 3. So remember, they fill one at a time, and then we fill in anything extra that we have. So 1, 2, 3 to get 6. So neon is actually diamagnetic as well. All right, so let's do gadolinium. Not really familiar with that one. I guess we'll have to go through it. Okay, nothing looks like gadolinium there. All right, Ga. That seems like a pretty good guess for gadolinium, and that actually is. Okay. So we start to get some strange orbital filling patterns as soon as we get to this D block here. I'm just going to say, you know what, I'm taking the MCAT. I don't get a lot of time for these questions. I'm going to focus on the last orbital filling part of it, which is going to be the P block here. And it's actually fairly similar to our 2p block. So I'm going to assume that there are 3 orbitals here. And I'm only seeing one electron in this column. So this is looking pretty good for being a paramagnetic element. So let's just make sure and go through. So argon, again, one of our noble gases, this is going to have 6 electrons and is going to fill very similarly to neon. So that's going to be diamagnetic too. So our correct answer finally is going to be gadolinium. And gadolinium, actually, practically speaking, is a contrast agent that we use in MRI. And it interacts very favorably in a way to create contrast due to its paramagnetism. So that one electron in that p orbital filling is actually really practically useful to us in medicine. And maybe you got lucky and you had volunteered perhaps in an MRI scanner and knew that gadolinium was a contrast agent. But for the MCAT, they really just want to test your knowledge of something being paramagnetic versus diamagnetic.